So let's take a look. Number one, the first one has k equal 25 and 100. So the p bar here is 96 over 25 multiplied 100. Right? That will give you 0.0384. Right? And then your standard error here is square root of 384 multiply 1 minus 0.0384 over 50. No, over 100. So we eventually have the p bar plus 3 standard error. So you eventually will get an answer A. Okay, hope all of you made it correct. The monitors the fraction of nonconformances. Fraction of nonconformances. Only P here monitors the fraction of nonconformances. Other things are monitoring the count. Each day, a manufacturing company producing circuit boards will randomly sample 60 circuit boards for a period of 25 days, then determine the number of defects contained in each of these boards. The appropriate control chart will randomly sample 60 circuit boards, right? 60 circuit boards for, I think the base opportunity size is the same here in this case. Therefore, I would vote for the C chart. Okay, base opportunity. So number 4, compare to the variable measurement. Attribute measurement requires to obtain the same amount of statistical information about the quality. Usually you need a larger sample size, right? A larger sample size to be able to obtain more meaningful observations. Number 5, if the lower limit for p bar computes to a number less than 0, this indicates that the lower limit should be set at 0. Okay, so number 6, if the variation in the control is due to common cause alone, the process is said to be in statistical control. Okay, it is in statistical control. It is not out of control. All else being constant, if the sample size in p bar chart increase from 100 to 120, the upper and lower control limit will move closer together. Therefore, you will have narrower control span, right? That's because your standard error will be smaller here. Number 8, a delivery company defines a defect as a package delivered later than the promised delivery time. Management wants to monitor the proportion of such defect package per week and plan to sample 120 package every week. The appropriate thing here, let's take a look. It's going to be, it's a, needless to say, a P chart, proportion, right? A company wishes to monitor the variation in the length of time it takes to process and send a bill to customer. 7 bills will be randomly selected each day. 7 bills will be selected randomly each day for 60-day period, and the length of time it takes to process and send a bill to customer will be recorded for each bill. The appropriate control chart in this case is A. Let's take a look. Okay, I paused a second because I was trying to figure out what is this guy actually asking. So they're trying to monitor the variation in the length of time, right? In the variation of length of time. So among 4, only A is measuring the variation in the process, right? So also it is using 7 bills. Your sample size is less than 10. Therefore, we're using the R chart. So number 10, company defines the nonconformances as an orange juice can whose diameter is beyond the upper spec limit. A manager at the canning company wants to monitor the number of such orange juice cans produced per day. Each day, employee will randomly select 120 cans over a period of 4 weeks. the employee then determine and plot the number of nonconformances can in each sample. So I think in this case, you will be plotting based on the fraction information, even though you're looking at the number of nonconformances, right? So it's a fraction based. So I think you can safely use NP chart for this problem. Let's take a look at the next one. Please answer the question based on the attached Excel file. Let me open it real quick. So the first thing it's asking, what is the number of samples, right? It's not asking the sample size. So with the characteristics of this data, so you're looking at 25 samples, right? Each with a size of 30. So here, 25, size of 30, okay? We'll answer the question based on the data in the previous question. What is the p-bar? P-bar being the overall defects. So you're doing is add them up, right? Divided by 25 multiply 30. So I think this has the answer here. If you look at here, sum them up, divided by 30 multiply 25, so that gives you 0.0653. 0.0653. What is the standard error? Standard error can be calculated based on this. So to save time, 0.045. 0.0451. Yeah. And the upper control, lower control. Upper control is here. I don't know why I didn't calculate the lower control limit, but let's take a look. If the sample contains 7 defects, would you consider it as an out of control situation? So I think I would consider it. Okay, I'll consider it. You can either convert it into NP chart, or even with the P chart, you can still obtain the answer. So you can just look up what is the corresponding count for your upper control limit, which is 20%. Okay, 20% of the 30, which is your sample, size of your sample, 20% out of 30 is equivalent to 6.02. So if you got 7, it's still more than 6.02. Therefore, it makes a out of control situation. Okay, so that kind of concludes this exercise.